In lesson 35, we're looking at angles and polygons, inscribed quadrilaterals, and fractional exponents. Our first example, we're just told to find x and y. Now there's a couple of things that we learn in this lesson, and one is to find the sum of interior angles, subtract 2 from the number of sides, and multiply by 180, and that would give you the sum of the interior angles. Now in this example, we do not need to use the interior angle sum, but that might help us later on. Now the next rule we learn is the sum of the measures of the exterior angles of any polygon is 360 degrees, and that we will use in this example. So what we're going to do is add all the exterior angles together and set it equal to 360 so that we can solve for x. So I'm going to have x plus 55, which I'm just going around here getting those angles, plus 80 plus 40 plus 50 plus 65, and that's equal to 360. Okay, then I add my like terms together, so I'll have 2x plus 290 equals 360. Then I'll subtract the 290 to move it to the other side. That'll give me 70, and that'll equal that 2x that was left on the left side of the equal sign. Then we'll just divide by 2, and then we found that x equals 35. Okay, so that's one of the variables we need to find. Now we also need to find this y. Now since this is on a straight line, the y degree will add with x plus 55 to equal 180. So I have y plus, and x is 35, so we're going to have 35 plus 55 equals 180. Then we'll add these together because they're like terms, and they're in parentheses. So that's 90 plus y, that equals 180. Then we'll just subtract the 90 to move it to the other side, and we find that y equals 90 degrees. So we found x and y. In our second example, we find x, y, and z. And in one of our previous lessons, we learned that if the angles are across from each other, they would add up to 180 degrees. So I know that y plus 75 would equal 180. So if I subtract 75 to move it to the other side, I find that y equals 105 degrees. Then for x, I know that x plus 80 would also add up to 180 degrees. So x plus 80 equals 180. Subtract the 80, move it to the other side. So we know that x equals 100 degrees. Now on z, we know that an inscribed angle that's on the opposite side of the circle, it would double to equal the degrees of the arc on the opposite side. So I'm going to say z plus 50, because that's what the 80 opens up to, the z and the 50 both. But that would equal 2 times 80. So z plus 50 equals 160, and then I'd subtract the 50. So move it to the other side, so z equals 110 degrees. So we have found our x, y, and z. In example 3, we move on to fractional exponents. And the first thing we need to do is to make this exponent positive. So I would take that under a 1, so it'd be like 1 over 4, I don't know, to the 1/2 power. And then that is the same as 1 over the square root of 4, and so it's 1/2. In the next one, you notice we have that negative on the outside, and it's not in parentheses or anything, so we're just going to leave it on the outside. But we're going to do the same thing and take this down to the bottom side of the fraction line so that it's 1 over 27 now to the positive 1/3. And again, I'm leaving that negative on the outside. And that is the same as 1 over the cube root of 27. So this is 1 over 3, and it stays negative. Okay, in the next example, you notice that we have a number other than 1 on top of the fraction. So there are a couple different ways we can split this up. So I could say that 16 cubed taken to the 1/2 power, or I could say 16 to the 1/2 taken to the 3rd power, or cubed. Now this second way makes it much easier to do without a calculator, because when I take a number to the 1/2 power, that is the same as taking the square root of that number, and the square root of 16 is 4, and then I would cube the 4 to get 64, and then that would be how it would simplify. You would get the same answer here, but cubing the 16 is a pretty big number. Okay, so let's do the same thing. Now again, this has a negative exponent like the first two, so I need to make the exponent positive first. So I'm going to say, take that down to the bottom fraction. So it's negative again, there's no parentheses, so I just leave a negative on the outside, and then we have 8 to the 2/3 power. And then I'm going to split this up, so that is negative 1 over, I'm going to say the cube root of 8, and then I'm going to say that squared. And this is the easier way to do without a calculator, because the cube root of 8 is 2, and then 2 squared is 4. So it's negative 1 over 4, so it's negative 1/4. Okay, so you want to keep in mind how those fractions work. Just as an extra example, if I had a 2 on the outside and I had 6 to the 4th power, this would be like 6 with 4 over 2. So the powers just divide, so that would be 6 squared to give us 36. And you can do that with any of the powers. You take the index from the radical and divide your power by that. So this would be 3, 6 over 3, which is 3 squared, so that's 9. Okay, so the index and the powers are just dividing. The index divides the power of the number on the inside of the radical.